viewers, welcome to my channel Easy Mathematics by Shelza Kapoor. So in the last video I had discussed about some properties of inverse trigonometric function that we are going to use those property in solving the exercise 2.1 from your NCERT book. Okay, so I suggest you to recall all the values that you have learned in your class 11th and the last video also, so that you can easily understand the every values. Okay, so let's proceed with the exercise 2.1. So here is the exercise 2.1. The question is find the principal values, right? So first equation is sine inverse minus 1 upon 2. Okay, students, we know that sine inverse sine of x is equal to x if this x belongs to what? This x belongs to the principal range of this sine inverse, and the principal range of the sine inverse is and close interval minus pi by 2 to pi by 2, right? So here is a sine inverse minus 1 by 2. So first you have to replace this value in terms of sine. So you can write sine inverse minus what is 1 by 2. You can write sine pi by, you can this is pi by 6, right? And students, you also know that minus sine of theta, you can also write sine of minus theta. Okay, so this is sine, you can also write minus pi by 6. Clear? So this is sine inverse sine theta, you can this is equals to what? Minus pi by 6, and this is the answer. Why? Because minus pi by 6 lies between the principal range, this minus pi by 2 to pi by 2, right? Students, you can also see that this is a pi by 2 and this is a minus pi by 2. So it means whatever the answer should be present in between the first quadrant and the fourth quadrant, and minus pi by 6 lies in the quadrant 4, right? So this is the correct answer. Now question number second. Question number second says cos inverse root 3 by 2. So again you have to replace this value in terms of cos. So what is root 3 by 2? So you can write this is a cos pi by 6, right? And you can easily write that this is a pi by 6 answer, because you know that your cos inverse cos of x is equal to x if this x belongs to what? This x belongs to the principal range of this, okay? So this trigonometric function, and this x belongs to 0 to pi. So this is the correct answer. Students, if the question like cos inverse minus root 3 upon 2, so this is cos inverse, this is your minus, and again what is root 3 by 2? This is cos pi by 6, okay? And I told you this is minus cos pi. You can't write this is cos minus theta, because cos of minus theta will gives you cos of theta. So whenever you find cos of minus cos of theta, always write cos pi minus theta, right? So there is a cos inverse, this is minus cos theta, so you have to write cos pi minus theta, and theta is what? Pi by 6. So by solving this you will get what? 5 pi upon 6, right students? And this is equal to what? Pi by 6 is the answer, because 5 pi by 3, 5 pi by 6 lies in between the principal range of cos inverse, and that is 0 to pi. Okay, question number 4 is tan inverse minus root 3. So again students, you have to replace this value in terms of what? In terms of tan, because tan inverse tan of x is equal to x when if this x belongs to what? If this x belongs to the principal range of this tan inverse, and the principal range tan inverse is what? Minus pi by 2 to pi by 2. So you can write this tan inverse minus, so you can write root 3. Root 3 means this is a tan pi by 3, okay? And you know that your minus tan theta, you can also write this minus of theta, okay? So this is your tan inverse, and this is what? Tan minus pi by 3. So this equal to minus pi by 3, because this minus pi by 3 is lies between the principal range of tan inverse, okay? So this is the correct answer. So in every question, by this method you can easily find out the answer, okay? So let's see question number 6. there is a tan inverse minus 1. So you can write tan inverse, and what is 1? So you can write tan pi by 4 again, and again this minus tan theta. It means this is what? Tan minus pi by 4. And this is equal to what? Minus pi by 4, because minus pi by 4 lies between the principal range of tan inverse, right? So now the question number 7, question number 8, question number 9, all questions are very similar, so you can do it by yourself. So next question number 11 is tan inverse of 1 plus cos inverse of minus 1 by 2 plus sine inverse of minus 1 by 2. So you can solve this one by one. So what is tan inverse of 1? Students, you know that what is your 1 in terms of tan is tan pi by 4, and this will equal to pi by 4. Why? Because pi by 4 lies between the principal range of this. It means there is a pi by 4, plus second is cos inverse minus 1 by 2, right? So this is a cos inverse minus, and 1 by 2 in terms of cos is what? 1 by 2 is cos pi by 3, right? But students, you know that your minus of cos theta, you can write cos pi minus theta. So you have to write this cos inverse, and this is a cos pi minus theta, right? So you can also see this. This is your pi minus pi by 3 means lies in the quadrant what? Second. And in quadrant seconds, only sine and cosec are positive. All quadrant values are negative, so you will get negative, and pi means no transformation occurs, so your cos remain cos. Okay students, so just solve this. So you will get cos inverse cos, this is 2 pi by 3, and this will equal to 2 pi by 3, because 2 pi by 3 belongs to the principal range of cos inverse, and that is 0 to pi. So it means cos inverse minus 1 by 2 means 2 pi by 3, plus what is sine minus 1 by 2? This is your sine inverse, this is your minus, and 1 by 2 is what? You can write this is a pi by 6, okay? And you can also write sine inverse, this is a sine pi by 6, and this will equal to what? Minus pi by 6 means belongs to, because this belongs to the what? Principal range of sine, and the principal range of sine is what? Close interval minus pi by 2 to pi by 2. So it means this is what? Minus pi by 6, okay? So when you solve this, you will get 3 pi by 4 is the correct answer for this question. Okay students, so before we proceed to exercise 2.2, there are some other important properties of inverse trigonometric functions also that are very useful for solving the exercise 2.2. So there are some properties. The properties is cosec inverse of x is equal to sine inverse 1 upon x, such that mod of x is greater than and equal to 1, and the second property is cos inverse 1 by x is equal to sec inverse of x, and the third is cot inverse of x is equals to tan inverse of 1 by x. Okay students, so when I'm talking about solving the question, so you can directly apply these properties, okay? You don't even have to consider these properties, these values of x, because these values of x are already valid or suitable for these properties. For example, the domain of cot inverse and the domain of tan inverse is what? All real numbers, okay? So all real numbers including 0 also. So if we take x is equals to 0, so your equation become what? 1 upon 0 means gives you not defined. So that's why the value of x is greater than 0. So you just have to consider, you just have to learn these properties, okay? You don't even have to consider, you don't even have to learn these values of x, right? So let's prove this property one by one. So for example, if I'll talk about the property number first, you have to prove this property. So taking left hand side, so let cosec inverse of x is equal to y. So what is your x? So you can write also this is cosec of y, right? And you can write cosec of y as 1 upon sine of y, because 1 upon sine is what? The reciprocal. Okay, right? And you can also write sine y is equal to what? 1 upon x. So you have to find out the value of y so that you can substitute the value of y in equation number 1. Okay, so you can write sine inverse 1 upon x. So by substituting the value y in equation number 1, you will get cosec inverse of x is equal to what? Sine inverse of 1 upon x. Okay, so by this method you can prove the other two properties also. For example, if I prove property number third, the property number third says cot inverse of x is equal to tan inverse of 1 upon x. Again, let cot inverse of x is equal to what? Y, right? So you can write x equals to what? Cot of y. And what is cot? You all know that what is cot? Cot is what? The reciprocal of tan. And you can also write this tan of y is equal to what? 1 upon x. So again you have to find out the value of y from here. So y is equal to what? Tan inverse 1 upon x. So again by substituting the value of y in equation number 1, so you will get cot inverse of x is equal to tan inverse of 1 by x. Okay, simple. The next property is sine inverse of minus x is equal to minus sine inverse of x, and tan inverse of minus x is equal to what? Minus tan inverse of x, and cosec inverse of minus x equals to minus cosec inverse of x. Students, you know that your minus of minus sine theta is equal to what? Sine of minus theta, right? Your minus of tan theta is equal to what? Tan of minus theta. And your minus of cosec theta is what? Is cosec of minus theta, right? So you can prove this by using this property of trigonometric functions. So let's prove prove property number first, right? So property number first says sine inverse minus x is equal to minus sine inverse x, right? So let sine inverse of minus x is equal to y, right? So you can write minus x is equal to what? Is sine of y. Okay, so by multiplying or by shifting this this minus to right hand side, or by multiplying minus by both side, you will get x is equals to what? Minus sine of y. And you know that your minus sine theta is equal to what? Sine of minus theta. So you can write sine of minus theta. Okay, true. So now you can also write your minus y is what? Sine inverse of x. And again you have to find out the what? You have to find out the value of y. So again by shifting this this minus to the right hand side, or by multiplying both sides, you will get minus sine inverse of x. So this is the proof of your property number 1. Okay, so by this method you can also prove the other two properties. So your next three properties says sec inverse of minus x is equals to pi minus sec inverse of x, and same case with the cos and the cot. Okay, and students, you know that your minus of sec theta is equal to what? Sec of pi minus theta. Your minus of cos theta is what? Is cos pi minus theta. And again your minus cos theta is what? Is cot pi minus theta, right? So let's prove property number 5. Okay, right? So again let cos inverse minus x is equal to what? Y. And here's equation number 1. Okay, so you have to so you can write minus x is what? Is cos of y. Again by multiplying minus on the both side, you will get x is equal to what? Minus cos of y. And you know that your minus cos theta is equal to cos pi minus theta. It means this is what? This is pi minus y. Okay, fine. So you can also write pi minus y is equal to what? cos inverse of x, and you have to find out the value of what? The value of y. So you can easily write this is pi minus cos inverse of x is equal to y. So by substituting this again in the question number 1, so you will get cos inverse of minus x is equal to what? Pi minus cos inverse of x. So again, by this method you can easily find out the other two properties also. Your next property is sine inverse of x plus cos inverse of x is equals to pi by 2, tan inverse of x plus cot inverse of x is equals to pi by 2, and sec inverse of x plus cosec inverse of x is equals to pi by 2, right? Students, you can easily learn, because if you remember your class 10th, your transformation, you can write this as cos pi by 2. This is your y. For example, this is your y. This is your sine of y. So you can write this cos pi minus 2 minus y, because this pi by 2 means the transformation occur, and the transformation occur from sine to cos. Here is a sine to cos, tan to cot, and sec to cosec. And transformation occur when you find there is a pi by 2. So you can easily learn with the help of that transformations. Okay. So by solving, so let's solve this property. So for example, if you solve your property number 1, okay, again let sine inverse of x is equal to what? Y. So what is your x? Your x is what? Sine of y, right? So you can also write, again student, this is what? You can write cos pi minus 2, pi upon 2, and pi upon 2 means a transformation occurs, means sine to cos. This is a transformation. And what is your theta? Theta is your y, right? So you can also write this is pi upon 2 minus y is equal to what? Cos inverse of x, right? So you have to find out the value of y from here. So you can write pi by 2 minus cos inverse of x is equal to what? Is equal to y. Okay, so substitute the value in equation number 1. So you will get sine inverse of x is equal to what? Pi by 2 minus cos inverse of x. And by shifting this on the left hand side, so you will get sine inverse x plus cos inverse x is equals to pi by 2. Okay students, so you can solve the other two properties by this method also. So your next property is tan inverse of x plus tan inverse of y is equal to tan inverse x plus y upon 1 minus x plus y upon 1 minus x into y. Okay, so let's solve this. So let's solve your property number first. Take let tan inverse of x is equal to theta 1, and let tan inverse of y is equal to what? Theta 2, right? So what is your x? Your x becomes tan of theta 1, and your y becomes what? Tan of theta 2, right? And students, you know that what is tan theta 1 plus theta 2? Okay, this is what? This is tan of theta 1 plus tan of theta 2 upon 1 minus tan of theta 1 into tan of theta 2, right? And what is your theta 1? Is x. So substitute x. What is tan of theta 2 is y. So write x plus y. And what is this? This is x into y. And on the left hand side there is a tan theta 1 plus theta 2. Okay, so you can write theta 1 plus theta 2 is what? Okay, this is tan inverse and x plus y upon 1 minus x into y. Okay, right? And what is theta 1? Theta 1 is what? Is tan inverse of x plus theta 2 is what? Tan inverse of y, right? And right hand side is equal to what? Tan inverse x plus y upon 1 minus x into y. Okay, and in the next part you just have to replace the value from x to y, change the value from x to y, minus to plus and plus to minus. Okay, the next property is 2 tan inverse of x is equals to what? Sine inverse 2x upon 1 plus x square, and to tan inverse of x is also what? Cos inverse 1 minus x square upon 1 plus x square, and is also equals to what? Tan inverse 2x upon 1 minus x square. Students, we know that this formula, that sine of 2x is what? 2 tan x upon 1 plus tan square x. tan 2x is equal to what? 2 tan x upon 1 minus tan square of x, and cos 2x is equal to what? 1 minus tan square x upon 1 plus tan square of x, right? So by solving this properties, for example, I solve property number second, okay, right? So in this property there is a one common thing, that is tan inverse of x, okay? So let tan inverse of x is equal to y, okay? So what is your x? Your x become what? Tan of y, okay? I proved property number second. So from the right hand side, take this value. This is 1 minus x square upon 1 plus x square, right? So what is your x? Your x is tan of y. So it means tan square of y upon 1 plus tan square of y. And this here is a 1 minus tan square of x upon 1 plus tan square of x is equal to what? Cos of 2x. So it means this is equals to what? Cos of 2y, right? And you can so it means your value is equal to what? Cot of 2y. And you can also write your 2y is what? Your 2y is cot inverse 1 minus x square upon 1 plus x square. And what is your y? Y is tan inverse of x. So you have to write y is equal to what? Tan inverse of x. And this is equal to what? 1 minus x square upon 1 plus x square. This is proved of property number second. And you can also prove property number third again by using this. So you just have to take the value on the right hand side. The value of the right hand side is what? 2x upon 1 minus x square, right? So again, by substituting the value of x, and what is the value of x? The value of x is tan of y, okay? By substituting the tan of y, your equation will become 2 tan of, here is a x, so there is a tan of x upon 1 minus tan square of x, and 2 tan of x upon 1 minus tan square of x is equal to what? Tan of 2x. And you can also write your 2x is equal to what? Is equal to tan inverse 2x upon 1 minus x square, right? And what is your x? X is tan inverse of y is equal to tan inverse 2 of x upon 1 minus x square. This is a proof of equation number, your property number third. Okay students, thank you.